Alright, so I hope I'm angled right here. So the instructions say if we're using a battery, $4,000 milliamp hour 35C, 8,000 milliamp hour 20C. I've got a 1,500 milliamp hour 100C. I don't suspect it'll work, but maybe it will. I do have a battery in my car, a proper lead acid battery. So, in reading this stuff, I recall them stating to not press hard Holy crap, it worked. Who frickin' knew? Let's see. And that's a 65 setting with that little dicky thing. Okay, so it was welded, but not super welded. So we're going to try this again at higher voltage, although it did peel. Yeah, I don't know if you can see, but the metal pieces stayed there on the base, and it put a hole, or ripped the so the weld itself didn't fail, just the surrounding material. Now, I'm guessing this is 10,000ths. I don't know if I have my, yeah, I do right there, it is. My micrometer out. So, yeah, it's 0.1 millimeter, 10,000ths. Well, 0.1 millimeter, that feels like that's about 15,000ths of an inch. Let's see what we have here. 40,000, no, 4,000ths. Must be the stiffness that causes it to feel thicker than it is. Anyway, it's 4,000ths of an inch thick, or 0.1 millimeter. Yep. Close enough. So what the hell? You only live once, right? Oh, son of a gun. That is pretty freaking impressive. Try not to slice my freaking cuticle or my nail bed. Yep, and it pulled off the metal again. Instead of the weld itself failing, it was the surrounding material that failed. So that tells me that I can very likely get away with a 3S LiPo that's got a little more ass to it. Although, in a pinch, this 100C battery seems to do its thing. So, I did add, or I didn't add, they didn't ship it, but I had, let me unplug it. Now, I'll show you the UI and then I'll unplug it. So basically it bounces between the power setting, that's 0 to 99, and then the voltage that's coming in. If you hold this A, they call it R, but I think it's an A. You can set that to 0 or 1. The 0 is instantaneous. As soon as it detects a drop in resistance between the two leads, it'll fire immediately. 1 allows the user to actually get the position and pressure onto the weld spot, and then fires after a second delay. The videos I watched, they suggested to not press real hard because it is a function of current flow, and obviously if anybody's knows anything about electronics, high resistance short create a lot of heat. So it kind of makes sense not to press super hard and defeat the thermal so yeah, I suspect 2 or more welds on a battery tab with this setup would probably work. So anyway, that's AR, that's the delay for firing the welding pulse. And then P is the output power level. 1 says standard power, 2 is enhanced power, and 3 is super power. I did that on a 1. I'm not going to push my luck, given I'm using a pretty small battery. They say 3S 5000 milliamp hour, 30C. They do say no more than 50 milliamp or 50 amp hours might damage the circuit board. So who knows? I might experiment and just keep using that. And I do have some 2200 milliamp hours, but I don't recall what the discharge current rating is. Oh, for fuck's sakes. $50C. So 50C at 2.2, so that's still 110 amps. And these 1500s are for my Yak 55. I've got a couple 1300s, a couple 1500s. I've got 6 of the 2200 50Cs. I might muck with those as well. Those are used on the Aero Scout, and I bought 3 thinking I was buying 3 batteries, but I actually bought 6 batteries. So, and that's not a bad thing, it is. It gives me some extras. So when I'm flying the Aero Scout or other 3S 2200 series birds, i.e. the Edge 540, I've got plenty of batteries. So, anyways, it's kind of interesting that this worked. So anyways, I added the fan. The case was provisioned for it. I happen to have a 12-volt fan of the right dimensions in stock. Right dimensions is a little misleading because when the fan was installed, if I had the board down using just the spacers, it'd actually touch. And I wanted some gap for airflowage purposes. So I ended up installing a spacer nut on each one of the shafts, screws to elevate the board a few millimeters. And it seems to have done its job. And then obviously, based on what I'm seeing here on the design, it looks like they're just routing power through, positive side through. And then they've got the timing circuitry and all that BS here. And then on the negative, they're using 8 MOSFETs switches to, when the circuit fires, to short ground input to ground output. And in that case, these MOSFETs are basically uber low resistance switch, and all of the battery current is pumped through the MOSFETs and out the negative lead. Obviously, electrons flow back up into the positive side, and through this bus bar are fed back into the battery. So what I did here is I happen to have from other projects some thermal tape and a plethora of heat sinks. I went ahead and added them, a series of them. 1, 2, 3, 4, 5, 6, 7 of them. Mechanically adhered to the top of the MOSFETs by way of that thermal tape. And what that is going to do is to help radiate the heat up and away from the MOSFETs, because those do get hot. I added the feet. The thought process I have is, if when I do get to using this thing more and more, if this gets doggone toasty, I'll throw a couple small 12-volt fans right here. I've got some 20 by 20s or 15 by 15s that are used on top of Raspberry Pis to cool the chassis. I'll put a couple here, and then might even 3D print a little duct to help air flow across the vanes and then out let the fan exhaust it. But we'll see. I don't want to over-engineer it now unless it's needed to be done, which it may not. So, anyways, that's that. You saw the test. The assembly of this was stupid simple. It was a $20 part. The fan was probably pack of 4, probably for $10, so we'll say $250, and another, we'll say $5 for the heat sinks and the tape. So let's call it $10 extra total, so $30 for the assembly I have in my hands. Not bad. I don't like the mechanical here. If the input side stays on, which it might not, if I'm just going to use lipos, then I'll just use the XT60. But on these, definitely, I'm going to get some, hell, I forget the flavor, the name of it, but there's a brand of heat shrink out there that has some super adhesive, and when it cools down, the whole thing gets hard as a brick. That is probably what I'm gonna do, and I may even get a while air up my ass and throw some solder at this to give it some mechanical rigidity. The problem is if you solder wire, solder wicks up the wire, and this high current, this is 12 gauge, I've got some 10 gauge as well. There's a lot of strands inside here, and then what happens is, yeah, this joint will be solid as all get out, but wherever that solder wicking stops, that'll become a potential failure point for the wire. So I may just get some of that heat shrink and slap it on there and call it good. We'll see. Anyway, I've droned on long enough. Have a good night.